Guys, I don't know if you are aware about the new theory of gravity initiated by Alzofon some time ago.
Yes, yeah. Well, and Lucian, Mark Sokol actually has been focused on Alzofon. That's his primary focus, is
Yes.
Alzofon's work.
I know, and we've met at the Tesla Extraordinary Conference, and I presented the new foundation for Alzofon's theory based on the quark model. So his theory is more of an effective theory, like thermodynamic take on the gravitational potential. But there was no justification why it should work, theoretically. And I explained that the structure of protons and neutrons in terms of quarks makes this mandatory. In other words, the existence of fractional electric charges and the distribution which corresponds to some Platonic solids makes it possible that if you orient the spin, then you affect the corresponding strength of the interaction of even two neutrons, which classically are neutral, but in the standard model, if you look carefully, so bottom line, Alzofon's theory has now a, let's say, a foundation, a new foundation based on particle physics, which I explained in some of my recent articles. And this, I would say, it's the way to go without speculations. It works.
Lucian, if I can interject for a second, can you tell us where people could read more about your work?
Yes, my articles are in the not in the electronic archive. It's in the VIXRA, the more flexible archive, electronic archive with respect to preprints. I could share my screen if you want, and quickly.
Sure, yeah. We're pretty mellow right now. We're in a holding pattern for Mark while he gets his 3-camera setup. Yeah, and Matthias just mentioned in chat, please paste the URL here. So yeah, if you have URLs, you can definitely paste those in chat as well.
Sure.
Yeah, so actually we met at the Tesla Tech conference in Albuquerque, New Mexico, where he was submitting the second theory. I've heard quite a few theories that are similar to Alzofon, which is why I wanted to get this group together. Charles, who was on earlier, also talked about a different variation of that. Todd has also talked in the past. So I want to really just go over the experiment and see what we can change based on all these theories. So Lucian, you want to dive into it? Give everyone your take on Alzofon?
Sure.
Okay, go for it.
So just a quick update since Tesla. At Tesla, I presented about quantum gravity and gravity control. And Alzofon Ionescu theory. I think you see the these preprints, right? I've shared the screen.
Yeah, and so we've got, it looks like it says vixra.org/author/Lucian_M_Ionescu.
Yes, and I pasted it in the chat file.
Perfect.
A quick update is that not only gravity can be controlled, but you can use the same technique to implement cold fusion. So that would be a really unexpected consequence of my my theory, which is not really complicated. It's very simple. The idea is that the symmetries of a proton or neutron are not the usual SO3, so they are not isotropic. if you assume that they have a finite group of symmetries, then you get the Platonic solids as configurations. So the electric charge of the proton and neutron will be arranged, say, at vertices of a Platonic solid. Now, this makes a big difference when two neutrons, for instance, interact. And maybe I should open one of those. So just the main point. So Platonic solids, first of all, corresponds to the what people don't understand yet, the quark flavors, and why there are only 3 generations of fermions. And this is exactly because there are exactly 3 groups of symmetry which are finite within, say, SO3. Now, gravity emerges because if you look, for instance, at the proton, which has 3 quarks, up, up, and down. Up has charge plus 2/3, down has charge minus 1/3. So now if you rewrite this in this manner, so 2/3 plus minus the correction to get the plus 2/3 plus 2/3 and minus 1/3, the correction is a 0, 0 plus. In other words, the distribution of electric charges in the proton consists of a first term, which is a Coulomb type of positive charge, isotropic, spherically symmetric, as if it would be a point. But then there is a correction which is oriented in one direction. So this correction is like a flow in the, say, z direction. And then when you, and this is responsible for gravity. Now the same thing holds for neutrons. So a neutron is really a 1/3 minus, minus, minus. So as if it's a pointwise negative charge plus a correction in the third direction of a plus charge. Again, note the direction dependence of this. So now when you put 2 neutrons in to interact, then it matters how you orient these second terms. And in this way, you can control this second term, which really gives gravity. So bottom line, now we understand exactly at the level of elementary particle physics why dynamic nuclear orientation, the one Alzofon is talking, really should work. And there is no more, if you want, mystery about that. The only problem remaining is to have some experiments which go beyond what he did and try to make this orientation more efficient. And for right now, I'll stop with this and see if there are questions or comments. What do you think about this new take on Alzofon's theory?
Yeah, I would say if anybody has questions or thoughts on it.
It's absolutely fascinating to me in my electrolysis cold fusion work I'm doing in my theory of everything with geometry and the Platonic solids combined with NASA's cold fusion through the what was it? The structuring of those bonds in the same platonic solid geometry. It's cool to see more connecting work on that same aspect of things.
I didn't know that there was also a connection, say, platonic solids cold fusion. If you can send to some reference, or
Jeremy, you posted if Jeremy Rice is present, you posted the link on Twitter that NASA did about a month ago with the structured cold fusion there. So I don't know if you have it available. I'll have to look it up. Sorry, Lincoln.
Okay, sure.
Yeah, Michael, did you have a question for Lucian?
Yeah, I'm curious about the spin, the proton's spin. Electrons have a spin of 1/2. So that means you have to get back to the original spin state, you have to go around twice. Is that the case for both the neutron and the proton?
Yes, fermions like neutron, proton. Actually, the quarks have spin 1/2. So depending on the orientation of the quarks,
Right.
I guess it can reach even 3/2. But proton and neutron,
Well, why couldn't you do
are in the group of
if you take
particles with 1/2 spin.
Yeah, the 2/3 plus 2/3 plus 1/3, wouldn't that give you 1 spin of 1?
That was the electric charge. Spin is actually not what's so important, but for each spin there is a representation. So the direction of the spin is important.
Well, my point is if you had a spin 1, then 1 turn it once, it comes back to the same spin state. While with the spin 1/2, you got to go around twice. So if you could have a particle, or you could have a quasi-particle that could have both states, for example, a 1 in one state and a 1/2 in another state, that would explain a lot of things that we observed, don't you think?
Again, I'm trying to share that again. I don't find my controls over here.
So other question in that regard, the graviton, when you hear about the spin state of a graviton, they say it's spin of 2.
Yes, but the theory of graviton, it's really not really proved or anything, and it's independent on the other interactions like electromagnetic, weak, and strong. So these are theories which were invented independently and are just theories. What I'm documenting in these articles is that there is only one unified force, which is the electroweak theory of standard model, but with a correction. So if you include these platonic solids as finite groups of symmetry in the standard model, in the electroweak theory, then you add gravity to it. And there is nothing else needed to complete the picture. So there is no graviton really. It's just a correction of the electromagnetism from a pointwise theory to a quark model theory. In other words, like two balls interacting, not points, when we refer to charges.
Gotcha. So it's not a point. It's not a point charge.
It's not a point charge. It's
Gotcha.
really, think of a platonic solid with the vertices being the sources. And at this point, it's not so clear how, for instance, 3 quarks distribute on a tetrahedron. So how the electric charges correspond to the vertices of the tetrahedron, for instance, or a cube or octahedron. This remains to be documented, analyzed a little bit more. But the point is, the moment you have not pointwise charges, but like platonic solids, then you have pluses and minuses, which total +1 or -1 or 0. But then, depending on how you orient those platonic solids, 2 of them, then you change the interaction between the 2. And for instance, 2 neutrons are in first approximation neutral, and gravity is the correction. So now if you reorient these neutrons, then you can make them repel or attract. Usually they tend to reach the lower energy levels, so they turn towards each other to attract.
So if you could change the neutrons' orientation to each other, you could change the gravitational effect on the gravitational
Yes,
effect on the solid, essentially. The weight, you could change the weight. Correct?
exactly. And this is done in a way similar to how a laser works. So
So
the
like-
laser pumps, lifts the energy levels in a coherent way in a cavity. Same here, if you can put them to vibrate. So first of all, you need an ambient electromagnetic field to, say, have a preferred direction, say the Z direction. And then when you...
Where'd your Justice?
You want me to get back on that? Are you,
Why is he in his car?
Oh, he's on the phone.
Oh. No, it's done. I'm just waiting for this guy.
Oh, yeah, it's all done.
Oh, I'm sorry. We
Mark,
Tim,
are you
are we
ready to? Well, so let me do this. So are you ready to go now, Mark?
I mean, yeah, we're ready to go. But
Okay, well, let me do this then. Let me do this. Let me put this on. Before we do that, you know what? I'm going to stop Lucian's screen share. I'm going to stop his screen sharing. And actually, everybody, let's give Lucian an applause for sharing his work with us
Thank you.
today. Lucy, we would love to have you back for a larger presentation as well. This is kind of impromptu. We had the time gap, and I appreciate you sharing. But yeah, we'd love to have you back for a longer, more detailed presentation.
Okay, sure. Thank you.
Absolutely. Absolutely.